Mathematics Analysis and Approaches, Paper 1, Time Zone 1, HL, May 2025. Now, this is question number 9, carries 8 marks. He has given us a homogeneous differential equation, and this is the equation for us, and he has given us that y is equal to 0 when x is equal to 2, and he has also told us what substitution to go with, which is y is equal to vx, and using that I need to basically find the solution of the differential equation. Since he has already told us that this is a homogeneous differential equation and the substitution has also been mentioned, we can directly use that. So what we have is dy by dx as equal to x minus y divided by x plus y. So I need to take y as equal to vx. Now I'm going to be differentiating this function with respect to x. So dy by dx is going to be, I'm applying the u into v rule, u into differential of v plus v into differential of u. So if I can rewrite that, I would have dy by dx as equal to v plus x dv by dx. Now I take the function, and wherever there is a y, I substitute vx, and in place of dy by dx, I'm going to be substituting v plus x dv by dx. So this is v plus x dv by dx is going to be equal to x minus y by x plus x. So x minus vx divided by x plus vx. So you can see that I can take a x common out from the RHS. So this is v plus x dv by dx, and that's going to be equal to x taken common out, 1 minus v divided by x again taken common out, of 1 plus v. So x and x will get cancelled here. So what I remain with is x v plus x dv by dx as equal to 1 minus v divided by 1 plus v. So after this point, I'm going to be trying variable separable. Most of the differential equations, they come down to variable separable at the end of it. Okay. So when I say variable separable, my goal is to put all the v terms along with dv and the x terms along with dx. Okay. So x dv by dx is going to be 1 minus v divided by 1 plus v minus v. I have x dv by dx is going to be equal to 1 minus v. After taking an LCM, this is going to become that divided by 1 plus v. Now, in the numerator, what I'll remain with is negative v square minus 2v plus 1 divided by 1 plus v. Let me do variable separable here. I'm going to write this as 1 plus v divided by v square plus 2v minus 1 dv, and the negative that I took common out from this term, I'm going to retain this over here on the RHS and write it as dx. And I can notice that when I differentiate the denominator here, which is v square plus 2v plus 1, I will get 2 times of v plus 2. So there is a 2 missing over here. For that, I'm going to be introducing a 2 and dividing it by a 2, or I could multiply both the sides by a 2. So 2 plus 2v divided by v square plus 2v minus 1 dv as equal to minus 2 over x dx. So you can notice that if I differentiate the denominator, I get the numerator completely, right? And therefore, I can write this integral as integral 2v plus 2 divided by v square plus 2v minus 1 dv is going to be equal to minus 2 taken common out, 1 over x dx. What do we know? We know that the integral of f dash of x divided by f of x dx, this is simply going to be ln of f of x plus c. Yeah, ln of f of x plus c. So that's what I'm going to be using here. So this will become ln of v square plus 2v minus 1, and that's going to be equal to minus 2 times of ln of x. Now, because I'm having ln for both the terms, I'm going to be writing the constant, but the constant will be a ln c. Please make a note of that. It's going to be a ln c. Okay. Now what? Further, I can write this as ln of v is equal to, from the substitution itself, v is going to be y by x. Okay, so I'm going to be going back and substituting v as y over x. So this is y over x the whole square plus 2 times of y over x minus 1. And that's equal to, I can write this as ln of mod of x to the power of negative 2 plus ln c. So this is ln of y square by x square plus 2y divided by x minus 1, which is further equal to ln of x to the power of minus 2 into c. So I can take out ln from both the sides, and also I'm going to take an LCM over here. So I'll have y square plus 2xy minus x square divided by x square, and that's going to be equal to c divided by x square. And you can see that I can strike out the c on both the sides. So what I'll now remain with is simply y square plus 2xy minus x square as equal to the constant c. So let's go back and look at the condition, the initial conditions that's been given to me, based on which I can find out the value for c. Y is 0, x is equal to 2. Let's go back and substitute that here. When y is equal to 0, x is equal to 2. So when I substitute that, I'm going to have 0 plus 0 minus 2 square is equal to c. That gives me the value for c is equal to negative 4. So I can take that and substitute it here. So I'll have y square plus 2xy minus x square is equal to negative 4. And if I'm multiplying the entire equation by a negative, I will have x square minus 2xy minus y square as equal to a constant 4. And that is what we had in the question. All right. That is it for this video. Thank you.